today we have Lisa Riggs, and Lisa is a regional consultant with the Kentucky Center for Mathematics. And Lisa, I look forward to learning from you this afternoon.
Well, I look forward to our session today, and the title is Habituation of the Basic Facts with Multiplication and Division. So we'll get started. This is my contact information, and you can reach me there by email if you want to continue the conversation. And just a reminder of our website, and if you have missed anything, whoops, sorry, I should have had, well, my animation isn't working on here apparently, but I did have an animation that pointed to the fact that today is more multiplicative thinking, but you can continue to look at our virtual site if there's anything that you missed in the past 9 weeks. It's housed there, so you can go back and catch up on anything that you missed, and at your leisure. So today we're going to just briefly look at the standards and some research. We're going to be looking at a few strategies and some good resources in this next 30 minutes. And if we have time, we may even have some time for you to test one out on your own. Okay. So just a reminder that our standards that we're going to be looking at are the 3rd grade fluency standards to fluently multiply and divide within 100. And using those relationships between multiplication and division and the properties of operations. So, and to apply those properties of operations as strategies to multiply and divide. Okay. And a reminder of some of the research that we have been using as we've thought about multiplication is Pam Weber Harris's development of mathematical reasoning, and in particular, the multiplicative reasoning piece. Okay. And you can, if you missed our talk about that earlier, you can find that at her website, Math is Figureoutable, and beginning with those counting strategies that students have, then thinking about the additive strategies, and next the multiplicative reasoning that we're working toward. It is that building. Okay? I love the graphic and how when we're thinking about multiplicative reasoning, it includes the counting is a piece that has started first, then that additive thinking builds from there, and the multiplicative reasoning is just the next step in that progression. And you guys can see that after we have that multiplicative reasoning, we want to continue with proportional reasoning and then functional reasoning as students progress in their mathematics. Okay. Another foundational piece of our look at multiplication is the foundational facts from Jenny Bay Williams' book, and I think I have it here, the Fact Fluency book that we have been thinking about and did our book study on not long ago. And it's just a reminder of how we can teach the facts, and not the way we may have learned them, certainly not the way I did. I can remember when I was learning multiplication facts, the way it was assessed was you stood in front of the class and you recited your facts in order, and once you were able to say them, you were checked off and moved on, and you know, you got a scoop of ice cream on the ice cream thing, and that's how it was. So we learned them in order, and they were kind of isolated, okay, and not and it was just by memory. Okay. So that's kind of the way, old school way of thinking. Okay. But now we want we see that if you remember in one of my sessions earlier, we talked about the 3 aspects of number. Okay. Does anybody want to unmute and remind us what those 3 aspects are? Don't be shy.
Okay, Lisa, it took me a while to remember. It's symbolic, quantitative, and word.
Oh, exactly. Yay, thank you. Okay, so verbal, the spoken, and then the quantitative piece, and the which one am I leaving out now? Symbolic piece. Okay. So if we're only thinking about kids using bare number facts and saying their multiplication facts, then that only has two of the aspects of number. Okay. It's leaving out that quantitative piece. So we want kids to not just be able to say their multiplication facts, but to really understand it in a conceptual way. What does it mean? What are we thinking about when we're thinking about when we're thinking multiplicatively? So thank you, Jennifer, for sharing that with us, because some of us may not have been here during that session. Also, from developing number knowledge, I almost just called it the Red Book, but for those of you that are math recovery trained, you do know this as the Red Book. Right? There are instructional phases of multiplication and division. Right? And the instructional phases, we covered some of these the last week that we did multiplication. Okay? So we started with those emergent strategies. Then you may remember the session that Dee did that was on the sequence of multiples. We did a whole session on that, the second phase. I did a session on structuring numbers multiplicatively and how to do that. Yesterday, Bonnie's session picked up on those developing strategies. And today, my focus is on that habituation of facts. Tomorrow we will focus on extending those multi-digit factors and moving beyond 100. So from the Red Book, there are some examples of strategies for different multipliers. Okay? So as we said before, we don't want kids to just say the facts, for example, 7 times 2. Okay? But we want them to understand what it means. And so for each of I just thought this was a nice chart to just give you some ideas of ways that we can help kids see that quantitative aspect of the multiplication facts and to apply a strategy to it. Right? And for example, this is one that Bonnie touched on yesterday. When we're multiplying by 2, if kids know there are doubles in an additive sense, they should be able to connect that adding doubles to multiplying by 2. Okay. Then if 3 is our multiplier, we can double, okay, work from that double and then add another. So for example, if it's 9 times 3, we just double the 9 and then add another group of 9. Okay. If our multiplier is 4, a strategy that students might use is double and then double again. So if our problem is 7 times 4, we can think, oh, well, 7 doubled is 14, and then I need another group of 14. Okay. If our multiplier is 5, we can think of our times 10s, which is kind of easy, and then half that. So we can think 6 times 5 is half of 60. Okay. Our 6s kind of get a little difficult for some kiddos. So we can think double 3s. So if we have learned our 3s previously, then we can think if our problem is 4 times 6, we can think, oh, well, I know 4 times 3 is 12. And if I do that again, that's another 12. So I can just add those together and get my answer is 24. And then you may find that the 7s and 8s are where lots of kids struggle to remember or have that habituation or quickly recall the answers to their facts. So they can use a previously known facts if they know their 5s or 6s facts. They can build from there. So for example, if the problem is 4 times 7 and they know their 5s, they can think, oh, well, 4 times 5, that's 20, plus the other piece would be 2, so 4 times 2. And if I put those together, then I know my problem is 28. Or if they know their 6s, oh, well, I can think 4 times 6, 24, and then another group of 4 makes 28. Okay. And then if we have 8s, once we get to 8s, we can think double and double and then double a third time. So for example, which is a nice strategy. Okay. So we can think if our problem is 6 times 8, double 6 would be 12. Then double 12 is 24. Double that is 48. So doubling it can be a strategy to build upon. Okay. Bonnie mentioned the nines trick with fingers yesterday, which is a trick. Okay. But we want kids to think conceptually. What does it mean to multiply by 9? So if we think, oh, well, I could just multiply by 10 and then take off a group, okay, that's a stronger conceptual understanding than just thinking about holding up fingers and counting and doing that nines trick. Okay. And for our 10s, students learn those pretty easily because it just corresponds with the 10's number. So 7 times 10 is 70 in those decade names. And so those are some of those strategies that, as I said, are found in table 7.1 in the Red Book on page 154, if you have that text. So a resource that I found is from Berkeley Everett, and in his blog post that he has some arrays that can help explicitly show multiplicative relationships. So if we take a look at this chart that shows some student thinking for 8 times 6. What are some of the strategies that you see that students have used to figure out 8 times 6? If you will either put it in the chat, which I can't see the chat, but somebody will fill me in, maybe, or unmute. That would be so nice.
I see partial products a lot, you know, where they're breaking numbers up, and well, they're all doing that. They're breaking numbers up to facts that they know. Like I know 2 times 6. I don't know 8 times 6. I know 2 times 6, and I know 2 times 6, and I know, and I keep doing that.
Yeah, so that's that double, and then double again, and
right.
then double.
I know and then I know my 5s. That was the next one, right? So
right, yeah. So
8 times 6, but I know 8 times 5 plus another group.
right, so that's that distributive property of that working with the 5 and the one more to break up the 6.
Mm-hmm.
Okay, that break apart. What about this last one? Anybody figure out the student thinking here?
Yeah, I was looking at that one. I thought it was interesting. You kind of see the 4 equal groups, but it's a different way to break it up. So it's the 4 groups that are 4 by 3.
Yeah. Yeah, so it looks like they've divided the 6. They've halved the 6, and then they've also halved the 8.
Mm-hmm.
So it's a half, and then to get their answer, double, right? So we can figure out it's 1 half.
Yeah, I could do the 12, and then another 12 is 24, and then 24 and 24 is 48.
Yeah. So
see the 4 times 12.
Yeah, the visual model is what helps to be able to bring that out and to see that kind of thinking. So in my PowerPoint, this is a link to his site, and I've included this handout in your packet of information. It has all the arrays for the basic facts, where you could allow students to use that array to demonstrate the way they're thinking about it, or you could use it to record student thinking. I think he has them in a PowerPoint format as well. So if you wanted to display it on your whiteboard or a Jamboard or something, you could be able to use a whiteboard to show student thinking and how they're seeing those relationships, because that's what we want students to do, to make those connections.
Lisa, in the chat, Stacy from Maryland has that question about habituation. Will you, she says, I'm not familiar with habituation of the basic fact. Can you just give me a brief explanation? And I know you're the expert on that. Will you just touch on that for a minute for everyone?
Well, I guess another way to think about that is that automaticity. We want students to be able to have recall based on the conceptual understanding. Not, so we've had that buildup of those phases. If I can, maybe well, for some reason, here we go. So we've had the buildup with these instructional phases. So this is not where we start. We don't start with just showing them a bare number task and expect them to just say them the way that I may have learned it when I was a kiddo, just to be able to recite, but to understand that when we say 8 times 6, we have that conceptual understanding of what it is. And I have had all these experiences, and then it allows me to have a recall that's based on that conceptual understanding. So it is kind of getting at what we want kids to do with our standard, right? To have that fluency, okay? But the fluency that is built on that foundation of conceptual understanding. Hopefully that makes some sense. And that answers your question.
It does, thank you. I just wasn't familiar with that term, but once you explained it, totally understood. Thank you so much.
No problem. Okay, now this is another graphic that I got from Berkeley Everett's website that shows the connection of the threes, how students can think about their threes and building on each other, and it's just a way for kids to record their thinking. So you can see that progression. If we know one group of 3, then we know if we double that, we're adding on another group, and there's the 3s at thinking of the double plus another group. Okay. And then our connection from 3 times 4 and how that connects to 3 times 8. We know those things. And I like the way that this is written down and the visual that's beside it. It just helps kids to see those connections. And 5s are easy for kids because if they can make the connection to skip counting by 5s, right, that's a good connection. And if we know our 5s, we can build to know our 6s is just another group. Okay. And once we know our 6, then we know our 7s is just another group. And our 9s are going to be one group less than the 10s. So it makes it, when you look at it that way, it's like, oh, this is not that hard. I like the way it says at the bottom. This is easy for me. Now, any comments about that? Okay. And there are some things that kiddos need to do in order for our facts to become a habit or habituated, is to practice with those. And practice with recalling what those facts are. And we start out with settings that are conceptual, but we want to distance from that setting over time. Okay? And the way to do that is through practice. So Orgo, as Bonnie mentioned yesterday, has a lot of good at-home activities available currently in our environment. So I just wanted to show you a couple of those, and one is called Pick a Product. Okay? And in this game, you're able to virtually roll some cubes, and then the kiddos decide, they pick 2 factors, multiply those 2 factors together, and then cover that product. And I think the way the game works is you try to get 4 in a row or in a square. So that's pretty simple. I'm going to see if I can go to it and let you guys see it. And actually, maybe not. It's not wanting to do that. Drat. Okay, well, maybe not, because it's going to want to make me sign in, so I'll just avoid that right now. because it's pretty easy to figure that game out. So we don't have to play that one. But it is a nice way for kids to practice, because they do need to practice with the, and if you put things in a game setting, it just makes it more fun for kiddos. So, but one of the things that our Red Book pointed out is once kids have their conceptual understanding of doing things multiplicatively, we also want to do things with our division as well. And we can do those in parallel, and we don't have to do them in isolation. So this is kind of a similar game, except you're using division expression cards to play missing divisor game as well. So we want kids working both multiplicatively to find products, and also to think in the inverse relationship there. So this is the game from Origo, Missing Divisors. And this is linked, and it should go to that game to be able to play that game virtually from Fundamentals. Okay, and there is one other game I'd like to share with you guys. And since I didn't get to play the others, I think I should be able to share this one with you guys in the chat. It is called Factors and Multiples, and it is from Enrich, the Enrich website. Okay, and I'm going to see if I can open up the chat maybe. Oh, there it is. I'll paste this in the chat and give you guys just a few minutes to try to play this game on your own. So if you guys, there is the link to Factors and Multiples. And the goal of that game, once you click on it, is to you decide where you want to start with what number, and then you can choose a multiple of that number next, and it makes a nice chain. And you try to see how long a chain you can make with factors and multiples. So I'll give you guys a few minutes to play that one. I should have some music. Okay, does anybody want to have any comments or questions about factors and multiples? Did you figure out how to play it? See some people saying that in the chat. It is, this game can get a little addictive when you start playing it. You want to try to make the longest chain possible. Some of the ones I have seen, about the longest chain I've seen did anybody make is 47 multiples. So it is kind of, it is fun and addictive, and to try to make the longest chain. So it's a nice game to get kids thinking about that. So hopefully you enjoyed that. Okay. But the point is to have kids engaged in practice of what they know conceptually, and applying those skills so that they have automaticity. Okay. And thank you, Amy, for putting that in the chat. I appreciate that. So those are, I think I'm going to be ending right on time today and not holding you over, but that is a few of the resources that I wanted to share with you guys, and just to help you to know that it's not just about saying the facts, okay, or being able to do a timed test, okay, and finish the facts in 2 minutes. But it is to recall those facts based on the use of strategies, properties, and conceptual understanding, and through practice and repetition, and seeing those connections and relationships, students can recall those, and it can become a habit of mind. Okay, so another little tip: if there is a certain fact that your student is struggling with, okay, putting that visual along with the fact, and along with the division fact, the multiplication and the division, and the array or the area model, and to see how can we conceptually think about that, okay, and putting that in multiple places. That was one tip that I had for my students when I was in MIT. If they were struggling with one, and it invariably seemed to be 7 times something or 8 times something would be the one that would trip them up. And I was like, okay, so this is your tricky problem. If this is your tricky problem, then hang this on your refrigerator, hang this on your bathroom mirror, in multiple places where they would see it multiple times a day and be reminded of it many times, okay, to help it become a habit of their mind. Okay, so that was another tip that I wanted to share with you guys. So as we always say, follow us on social media and at our website, and we will continue our sessions this week. So Kelly, if you have anything else you would like to add?
I do see several new people or new names, and one of the things that we like to mention are some of the resources that we are in love with. And so when Lisa references the Red Book, it is indeed, this book is the cornerstone of the courses that we do for KCM. And then there does not go a week that book is not referenced in one of our Zoom sessions. I dare say that if we had in place in every classroom across Kentucky the principles that are found in this book, we would be in great shape. So we would be in great shape. So indeed, Lisa, thank you for reminding us about the habituation of those multiplication, thinking about always students needing that automaticity, but it's not about a timed fact. In the chat, we'd love for you to give Lisa some props. She spent a lot of time really thinking about the math that's in there, and everyone, of course, enjoys your activities. Your handouts are fantastic. Jennifer's giving you a round of applause, or her little clap. So we thank you. We thank you so much. Indeed, many of you have been KCM friends for a long time. So that's one of the things that we want to tell you, how much we appreciate your dedication to the Kentucky Center of Mathematics. And indeed, Amy has her Facebook, her very, very vibrant Facebook site. And she says, everybody on Facebook loves it when Amy shares. She also does the viewing parties, so it makes a difference. Anyone want to unmute and tell Lisa what their favorite part of today was?
I just want to say thank you for all the online tools and games, because especially with the way things are right now, we don't know what type of platform we'll be going back to, and all this will just be so helpful if we have to do more days at home or virtual learning. So thank you so much for all that.
Fantastic. That is indeed our goal, is to help you guys as artisan teachers, classroom teachers. Are really devising beautiful learning for your students. So from the Kentucky Center for Mathematics, we have more developing this multiplicative thinking tomorrow, and we look forward to seeing you. See you guys.